Okay, so we first heard about this through the many contacts that I have with researchers at the Dow Chemical Company. It was a new initiative from Dow, and we were very excited about what it could do, not only for the Materials Research Laboratory and the various departments, but I think as campus as a whole. What this now allows us to do is to not only support applied research that builds on our fundamental findings, but it allows us to train our students in what I think is a much more appropriate model than traditionally followed at many other universities, giving them exposure to industry where many of them will actually find employment after they leave UCSB is exactly what we need to do. And by combining that with cutting edge research and also research that actually has a purpose, and the questions that Dow will allow us to ask based on their experience is worth its weight in gold. So these are the many things that the Dow Materials Institute will bring to UCSB. So in my own research, one of the fundamental issues that Dow will be essential for us to be able to answer is in developing new materials for advanced microelectronic devices. As Moore's law pushes and pushes to smaller and smaller feature sizes, less than 20 nanometers, traditional photolithography is running out of steam. It's running into physical limitations. We've developed recently directed self-assembly. And again, we've done fundamental work. We've shown we can get various patterns, we can control feature sizes, but the translation of that to an actual product is enormous. We cannot do that alone. Simple fact. By partnering with Dow, we not only can make a number of steps towards that goal, but also Dow can tell us exactly what manufacturers need. And so that combination is extremely powerful and really does allow us to take this fundamental work that we've done over a number of years and now actually translate it to actual products.
Well, this is really an important validation, in my view, for the work that our faculty do, the research, for the students that we have working on those projects, the quality of the students, and perhaps most importantly, the access that we will get to Dow researchers to be able to collaborate with them, to be able to really get behind what the pressing engineering and science materials problems are of our day as viewed from Dow's perspective, because in the end, they're the ones that are trying to commercialize new products and new materials in order to meet the needs of modern society, whether it's sustainability, whether it's new forms of energy, and so on and so forth. And we already have very good research programs in those areas ongoing, which presumably is why Dow wanted to come here in the first place. But the researchers at Dow really understand what it takes, what kind of scientific breakthroughs it takes to be able to create a new product that society actually is willing to buy. And we don't have that experience in the university. So I see the collaboration with Dow researchers as being a really critical element in this new venture together. We have tremendous faculty who are hungry for success. That's one thing. I don't see anybody in the chemical engineering or the materials departments who are sitting on their laurels and let's say enjoying the fruits of a successful career and just coasting along. One of the wonderful things that I find in both of these departments is everybody is eager to keep moving on to the next discovery, through to the next breakthrough. And that's not true everywhere. I mean, we've got faculty as old as in their 70s who still behave like assistant professors, And we have assistant professors who behave like assistant professors. And it's in my experience here, everybody gets up in the morning and just wants to go to work. And it's a very invigorating place. We collaborate a lot with each other, and because of that you learn a lot, and when you're learning a lot you want to keep pressing ahead. I collaborate with 3 different professors here on campus, and it's so exciting to make suggestions and have your colleagues in the room with you as well as your students who are, let's say, improving on those ideas and suggestions. And I don't want to go into the details because they're kind of technical, but many of the recent projects I've been involved in could not possibly have happened out of my group alone, or out of, for instance, Baron Peters, one of my collaborators, out of his group alone. The things that we are doing together with our doctoral students are a unique intersection of my skills and Baron's skills. And our students are the better for it, and I think the research is the better for it.
Well, UCSB is absolutely top tier, as we well know from our collaborations with UCSB, but also reinforced by the National Research Council rankings, both material science and chemical engineering. And that alone is significant, but what's most significant is the collaboration that we see on campus. That you've got top faculty who have the capacity to attract the very best minds in the world, who actually can leave their ego at the door and face challenging problems and collaborate in an environment learning with each other. And that, quite frankly, attracts the types of students that thrive within an industrial environment. The problems that we face are ones that neither solely a chemist or a material scientist or a physicist or a chemical engineer alone can solve. And so those departments that from the very beginning attract talent that can think in a cross-disciplinary way and support problem solving in a cross-disciplinary way, and also embrace working with industry in a collaborative way. Those are the institutes that, quite frankly, are most important to us as we move forward. But frankly, when the proposal of forming a Dow Materials Institute, which again was a discussion between all of us in this room a number of months ago, Mike and Craig, Glenn Fredrickson, was an appreciation of the power of we, both at the university, as well as our researchers who, quite frankly, had gone about addressing what were the critical breakthroughs that we felt were going to be important for our company over the next 10 plus years. And we challenged our researchers to bring these questions back to us. We challenged them to identify who would be the collaborators across the world that they would choose as their first, second, and third. And out of that emerged a critical set of programs that we, quite frankly, felt that we must work together with UCSB. And so that's the foundation that we're beginning with the formation of the Dow Materials Institute. The beauty of the Dow Materials Institute will be bringing representation from the university from each of those departments, as well as our key scientific leadership within our corporate research and our business research, in being able to have an exchange, both on progress of the programs we have in place, as well as new ideas. New questions from our side, new opportunities, as well as new ideas, and then over time continue to reinforce and support and bring on new programs. So we're incredibly excited about the future in front of us, and particularly around the ability to train the next generation of scientists and engineers.